Welcome to Chemistry Spot. Today, we will understand an important concept. Why are the ionic radii of negative ions in period 3 larger than the ionic radii of positive ions? Let's explain it step by step, slowly and clearly. First, what is ionic radius? Ionic radius means the size of an ion. In simple words, it tells us how big or small an ion is. Now remember, in period 3, some elements form positive ions, called cations, and some elements form negative ions, called anions. For example, sodium forms Na, magnesium forms Mg3 are positive ions, while chlorine forms C≡ forms S3 are negative ions. Now the question is, why are negative ions larger than positive ions? The first reason is gain or loss of electrons. Positive ions are formed when atoms lose electrons. For example, sodium loses one electron to become Na. When an atom loses electrons, sometimes it loses its outer shell completely. Because of this, the number of electron shells decreases, and the ion becomes smaller in size. That is why positive ions have smaller ionic radii. Now let's look at negative ions. Negative ions are formed when atoms gain electrons. For example, chlorine gains one electron to become Cl. When extra electrons are added, the number of electrons increases, but the nuclear charge stays the same. This causes more electron-electron repulsion. Because electrons repel each other, they spread out more. As a result, the ion expands, and its size becomes larger. That is why negative ions have larger ionic radii. So the main idea is simple. Positive ions lose electrons, become smaller. Negative ions gain electrons, become larger. This is why, in period 3, the ionic radii of negative ions are higher than the ionic radii of positive ions.